So we move on to the next speaker. So the next talk is a pre-recorded session by Jonathan Lee. He's an Assistant Vice President of PSA Corp Limited. So let's listen to this pre-recorded video.
Good afternoon, ladies and gentlemen. Today, I'll be sharing with you PSA Singapore attempt to develop the first autonomous key crane. Despite the popularity of a fully automated yard, there is limited quayside automation in the port industry today, unless a port is deploying AGVs as a horizontal transport. For majority of existing ports that are operating with trucks as the horizontal transport, it is difficult to achieve human productivity savings when automating the key crane, as a remote operator is still required for each crane to perform the following. To supervise a spreader during automated trolley movement between the vessel and wharf site, and to perform the last mile of container handling on the vessel and truck with the assistance of video feedback. The picture below shows the various automated key crane subsystem that PSA has been testing over the last few years. PSA has successfully tested wharf automation with trucks through high-resolution scanner for truck and container positioning, plus video analytics for human intrusion detection. However, there are greater challenges when one is attempting to automate vessel side operation. The presence of workers around the containers on the vessel, the limited view during underdeck operation, and the non-standardized cell guide. The need for humans to perform lashing and twist-off removal activities aboard vessel poses a great safety challenge. In this video, a lashing worker is needed to remove some stuck twist lock from the top of the containers that are under the spreader. This video shows the challenge an operator faces when performing underdeck operation. The operator is trying to align the four corners of the spreader to the cell guide entry guide. This is to position the spreader accurately above the target container in order to navigate the spreader through the cell guide. For undertake operation, the operator will have to align the spreader or container to the vessel cell guides in order to pick up or set down the container. As there are no international standards on cell guide design, different vessels can have different designs and dimensions of cell guides. With vessel operating in a harsh environment, be it due to weather or the operator's handling of the spreader against the cell guide, the contour of the cell guide's entry point might deform over time. This poses further challenge for the spreader container to fit within the cell guide structure for swift operation. Together with SMI, PSA is developing the first autonomous key crane. We will equip the crane with multiple sensors to achieve quality static measurement of the ship structure. We'll develop a real-time digital twin based on historical and sensor data. It will be powered by a self-learning AI on how an operator navigates a spreader through the ship structure to achieve autonomous navigation of the spreader through the ship structure. PSA is extremely grateful to have SMI alongside with us in this journey. Thank you.
Thank you, Jonathan. Is Jonathan online? Right. Hi, Jonathan. Is there any questions for Jonathan from the floor? Okay, maybe I just ask one question. May I know what is the current progress of this autonomous system of the crane?
Okay, currently we are testing is still on the semi-automated mode. Currently, with SMI, we have actually a grant call, which we are at the final stage of awarding. And it's expected that we'll be awarding the grant call somewhere at the third quarter of this year. And then we have a target of 2 years to work with the university to achieve this first fully autonomous key crane in the port industry.
All right. Okay, thank you. So if there's no more questions, maybe we move on to the next speaker. Thank you, Jonathan.
Thank you very much.